there's a lot of people know that it is an exact of people feeling where people feel for so there were errors. So the problem is that the problem is we have modern usually it is done for even different it is possible and it is not having to so it will be a problem after we will discuss it further down the line. So for the unit point, we said that you can predict that. So you can create a trend analysis. So what is the data pointing towards to and prediction outside the limit of details or extrapolation if it is within the limit of given data within the terminal or critical. Now we can try to see this data set and the curve we want to represent this data entry. Using a hypothesis testing, there are ways to measure the accuracy of your assumptions of what you have. And you can pose an argument of this data model, call it the model, not how the model is. Now, let's say you imagine experiment. Let's say you have your cylinder that flows through an air within the cylinder. So expand the air and then the air is very increase and then the velocity of air increases that. The static transfer of fan and then all throughout the it's like so we imagine that we connect a string A and then attach to the prediction. So with our respective velocity of the air, we can see a respective change in the force or the spring field in this measurement. So maybe we can establish a relationship between the velocity in the cylinder and then the force experienced by this spring. So if the velocity is set, we can imagine this can happen that if we have the velocity, so for some velocity there will be no force because the wind may not be strong enough to create drag and if you increase the velocity, it creates some force here. So there will be a force here and then so as you increase the velocity, you will see there is an increase in the force experienced by this spring field. So maybe you can create a way to represent this relationship. So we want to find out what will be the force if let's say 100 meters per second is our velocity. So if it's outside of the data, so we will extrapolate. We can say let's say a function with a particle force and then calculate what is this force here. So that is the regression. Wherein we're trying to find a curve that best represents or minimizes this error. So there is here is the difference between the prediction and the data. The prediction and the data, so we have this error and we want to relate this difference between possibility. Okay? So we have the error as the difference between the data and the prediction function of our research data. So the y here is the actual output and the sample will give us actual input. And the y of x will be the approximate output as a function. So we do not know the function of the but we can provide that the linear it could be a linear function, but it might be also a quadratic. It might be a quadratic. We don't know yet. We can analyze this. This makes now, I think if you find this, if we have more than one response, we can sum the errors here from the previous side, here. If on the previous side, cumulative errors here are cumulative. We can find the sum of these errors, and from these errors can be scaled. So why do we need to scale this? Because the errors will be the same regardless of its time step. Let's see now, if we analyze this, if there's a positive or a negative error, if it's actually a negative error, then this will be a positive error. So, if this is negative error, negative error, negative error, negative error, positive error. So, because it's a good time, still an error, but good reading. So the goal here is to minimize this here, of this error. So, solve for it next line. So, the summation of this error is equal to now to minimize this, we have different ways to minimize this. We can actually use derivatives. We say the minimum the minimum error expected to that parameter. It's really hard to describe now. Sige, let's just consider 4 cases. We have linear, polynomial, multiple linear, and nonlinear. Now, let's begin with linear regression. So for linear regression, we have an interesting media here. And let's say this red dots represent these data points. I'll just close this. Sorry, I'll just check. What is the time? Ayan. Okay, sorry. So, if this is the data, we want to find this curve, this linear, or this line that represents this data set. So, we can impose a parameter, no? So, this is called a parameter. So, A0 and A1. And what we can do here is we want to find this A0 and A1 that help us describe this line. So, we can imagine if you have a line, you have this actually this is the intercept and this one is your slope. So to describe a line, you usually have a minimum of two things, no? You have to have at least 2 points, you have a slope and a point, or in this case you want to find the slope intercept or the y-intercept and the slope. So if you want to minimize the sum of the errors, which is SR, or what we called last time, that is phi, how do we find the minimum or the minimum of this function? So we want to find the minimum of this function, we can use derivatives. So if you find the derivative of this, since this is a function of difference of two functions, or actually, sige, we can try simplifying this first na lang, no? So this SR, this is equal to, we know that this is equal to A0 plus A1x, ayan, or xi to be exact. So this will be yi minus A0 minus A1xi. So I distributed the negative sign for this two, ano? So this should be positive actually, but distribute the sign, it will both be negative. And then square this. So we have two unknown variables here. So these are given, no? These are given data points, a collection of data points at n values. So to find these two variables, now we can categorize this as variable at this case. We want to solve for the minimum values of A0 and A1. And to solve for that, we can use the derivatives. So to be exact, since we have two variables, we want to use the partial derivatives. So we can find the partial derivative with respect to r. So del SR with respect to, let's say, a naught. Okay, so finding the derivative of this, how do we find the derivative of a power series? So for series, we can just do the similar approach. So we can use the power rule. So we have here 2, and then find the derivative of a naught, no, in this variable. So everything else is treated as a constant, so this will be 0. So treated as 0, so 0. And then what is the derivative of negative a naught? So negative 1. So therefore, the answer here, we have negative 2, so 2 times negative 1. And then the summation of I is equal to 1n, and then we have yi minus a naught minus a1 xi. So we reduce the exponent to 1 due to the power rule, so this will be just 1. Okay, so now to find the minimum error, we can equate this to 0. Okay? Okay, so let's set this aside for now, and then let's find the partial derivative again of this function with respect to the other parameter, or in this case, the variable a1. So again, power rule again. So 2, and then summation of I is equal to 1, and then find the derivative of this via the chain rule. So this is 0, yi is 0, a sub 0 is 0, and then this will be, so what is the derivative of negative a1x? So what is the derivative of this? So this will be actually negative xi. So this will be negative, a negative side here, and then we cannot actually we cannot factor out a variable in a series. So the xi should be within this series, and then again we can equate this to 0 since we are trying to find the minimum, in if you can recall in your derivatives. So we can simplify this further. We can simplify this further by dividing this both sides by negative 2. So actually you can divide this by negative 2 and nothing will change, no? So we have the summation of from I is equal to 1 of n yi minus a0 minus a1 xi is equal to 0, and then we have here for the other one, we have I is equal to 1, then we have yi. Actually we can distribute also this xi if you want. Yes, you can distribute this xi. So we have yi xi, I'll just make this xi yi minus a naught xi minus a1 xi squared is equal to 0. So for this one, we can actually distribute this sign, no? So there's a property for series that we can distribute this sign. So we have I'll just write here the summation, just to save time. So the summation of yi minus the summation of a naught minus the summation of a1 xi is equal to 0. And then what we can do now, we can transpose this 2 to the other side, or swap this to the other side as well. So we have the summation of a naught plus summation of a1 xi is equal to summation of yi. Okay, so now actually yung summation of a naught, what is the summation of a naught? So basically we're just multiplying a naught a bunch of n times. So we can actually rewrite this as n times a naught. So the equation that we can form here is n times a naught plus we have summation of a1 xi is equal to summation of yi. And then for this portion, we can also distribute this. So we have summation of xi yi minus the summation of a naught xi minus the summation of a1 xi squared is equal to 0. So we can again transpose this to the other side and then swap their positions. So we have the summation of a naught xi plus the summation of a1 xi squared is equal to the summation of xi yi. That's it. So if we have these two equations, so equation 1, equation 2, we can see that we can set this up, no? So equation 1 and 2, so 1 and 2, so we have n a naught plus summation of a1 xi is equal to summation of yi, and then the second equation is the summation of a naught xi plus the summation of a1 xi squared is equal to the summation of xi yi. So as we can see, what are we trying to solve here is a1, no, and a naught. And actually, a property of summations, no, or series, power series, or series in general, summation of series, is that we can factor out the constant. Actually, this is a constant in this context, no? So we can rewrite this as NA sub 0 plus A1 summation of xi is equal to the summation of yi, and then we have A naught summation of actually I'll just swap this position, no? So we have xi and then the a1 here, and then we have the summation of xi, and then a sub 0 plus we have the summation of xi squared. Actually this should be inside, no? And then a1 is equal to the summation of xi yi. So as we can see here, does this look familiar, no? So we have a system of linear equation, diba, that has an unknown of a naught and a1. So we can rewrite this as in matrix form, we have n, the summation of xi, the summation of xi, the summation of xi squared, and then we have the unknown a sub 0 and a1, or a naught a1, and then we have the summation of yi, the summation of xi yi. So if we solve this system of linear equation, we can solve for a naught and a1. Diba? So we should remember this formula for solving the values or the constants a sub 0 and a1. So again, no, we have this formula. Then for solving this, actually there is a shortcut, or if you do not want to use your calculator effectively, you can memorize this formula. If you solve this analytically, you can solve for this. This is the general solution. But since we have a calculator, we can just input this in our calculator na lang, no? To save time. Okay. So now, how do we know? No, the question is, how do we know if our linear regression or our regression in general is accurate? How do we describe that? So the accuracy of your regression line will be a factor or a function of these two parameters. So we have s sub 0, which is the spread of data around the mean. You can imagine this is the standard deviation, and then the spread of data around the regression line. Okay, which is this error. Actually, this is error, no? Or the sum of these errors. So the sum of errors for this, and then the sum of the deviation from the mean. Okay, so using this two formula, we can find what is called the coefficient of determination, which is the r squared, no? Which is a function of s sub 0 and s, which is again the spread around the mean and the summation of errors, the s. So this represents the accuracy of your regression. So be mindful that the r squared should be in between 0 and 1 only. So remember again, 0 and 1. So if it is closer to 1, accurate. If it is 1, it is perfect, no? If it is closer to 0, then it is inaccurate. Inaccurate prediction. That is what you should remember, So let's try solving this simple problem here. So use linear regression to fit the following points, then compute the coefficient of determination r squared to gauge the goodness of fit. So how do we do this now? No? So as we can recall, no, if you have two pair or a pair of data set, then we need to what, no? We need to use the formula na lang. So the formula for the regression is, so for me, I just memorized this matrix, no? So we have n here, summation of xi, summation of xi, the summation of xi squared, and then we have a sub 0, a1, and then equals to, we have here
the summation of x, sorry, not summation of yi, and then this is the summation of x I, yi. Yeah. So we should determine, to solve for a naught and a1, we should determine what is n, this one, this one, this one, and this one. So we need to tabulate our solution. Ano? So for xi, we already have the xi here. So yeah, I will write this down again. No? So we have xi, we have 1, 2, 3, 4, and 5. For yi, we have 0 0.7, 2.2, 2.8, and 4.4, and 4.9. Yeah. Now, what is n? So n here is the number of data points. So meaning how many pairs? So we have 1, 2, 3, 4, 5. So we have 5 pairs. So the n here is equal to 5. Okay, we are solved for n. So I'll just erase this first. We want to now find the summation of x. So the summation of x, guys, is the total here, no? So the summation of x is, we have, this is, I'll just write this down, no? I calculated this already just to save time. And then for the summation of xi squared, okay, we can calculate this later, or we can already solve this. Yeah, let's create a new column here. That is xi squared. So we have xi squared. So we just want to square this. So 1 squared is 1, 2 squared is 4, and so on. So we have 1, 4, 9, 16, and 25. And then to find the sum, so the sum of the xi squared, no? So I'll just write this down below. So this is equal to, I have a calculation here, which is 55. Okay, so we are good here for the coefficient matrix. Now for the summation of yi, so the summation of this, so we just add this, all of this, we have, this is also 15, no? So 15. And then for the summation of xi and yi, so what we need to do is multiply the xi and the yi, no? So multiply this, x and y, so we have 0 0.7, and then 2 times 2.2, so what is that? I don't have a calculation pala, no? So yeah, I'll just calculate anyways. So the calculation here, we have 2 times 2.2, we have 4.4 pala, no? 4.4, 3 times 2.8, we have 8.4, and then 4 times 4.4, 4 times 4.4, so 17.6, 17.6, 5 times 49, so that is 245. So the sum of this is equal to, so we can just find the sum. We have 0.7, 4.4, sorry, 4.4, sorry, plus 4.4 plus 8.4 plus 17.6 plus 245. So we have 276.1, right? I'm just gauging if I'm correct, no? This doesn't seem correct. Why is that? 5 times 49. 4.9. Okay, sorry. This should be 4.9. So, we have to change this. So, 4.9 times 5. Oh, sorry. So, 55.6 only, no? So, this will be 24.5. We have 55.6. So, the summation of xi, yi is equal to 55.6. Okay, so we already have this for everyone, for everything here. So therefore, we can now solve this. So using the matrix, we can just substitute the values here, which is 5. Summation of xi, we have 15, 15. And then summation of xi squared, we have 55. And then a naught, a1, and then we have yi, we have 15. And then 55.6. Yeah, so equal sign. And then solving this, we can already have a value of a naught and a1. So using your calculator, you can just use the equation function. So mode 5, and then the first one, 2 equations, 2 unknowns. So 5, 15, and then 15. So just write the first row here. Then we have 15, 55, and 55.6. So the answer should be negative 0.18, and the other one is 1.06. 1.06. So therefore, our linear regression, so the linear regression, what is the linear regression? The linear regression is y of x is equal to a naught plus a1x. So this will be negative 0.18 plus 1.06x. So this will be your linear regression. So this will be your answer. So this represents the curve. Ano? This data points represent, or this curve represents this data point. Now, if we want to find the r squared, so how do we find the r squared? There will be a lot of computations here, no? So for the mean, now we need the mean. So the mean is the summation of all the y, no? Over n. What else? So to find the sum of the deviation around the mean, we have s sub 0. That is the summation of y minus the mean of this y variable, and then squared. And then for s, we have, since this is linear regression, the summation of y, this should be yi pala, no? Yi, and then yi minus a naught minus a1 xi, and then squared. Sorry. So we should find first this, and also this one, no? But, sorry, I need to erase this. Yeah. So therefore, we want to also compute for the mean. So the mean is equal to, if you want to find the mean, that is just the average, diba? So the average here is, so this the values of y is 0.7 plus 2.2 plus 2.8 plus 4.4 plus 4.9 over n. So n here is 5. So the mean here is 3. So the mean here is equal to 3. So we can use this. And then to find y minus y bar and then squared. So we can just do this directly, no? So to make things faster, we can just subtract this y. So this is the yi. Sorry, this should be yi. And then minus 3. So we have 0.7, for example, 0.7 minus 3. So this, and then squared. So this will be equal to 5.29. And then continue, no? So this will be 0.64, 0.04, 1.96, and then 3.61. So the total, no? So the SO, which is also the summation of yi minus y bar squared, this is equal to, the calculated here is 11.54. Yeah. And then for this one, so we want to figure this out. Okay, so yeah, we have here yi minus a naught a1 minus a1 xi, and then squared. So how do we calculate this? We can just substitute the value of x here to find this portion, no? So yi is just 0.7, and then minus, we have, this will become positive, diba? So we have plus 0.18, and then this will become minus 1.06. And then xi is, so the xi here is multiplied by 1. So I'll just write here 0.7 as an input. So this should be equal to 0.0324. Ayan. And then you can do this as well for the other rows. So we have here 0.0676, 0.04, 0.1156, 0.0484, and then the total of this, so S is equal to the summation of yi minus a naught minus a1 xi squared is equal to 0.304. Okay, so the last thing we should do here is to solve the r, no? So the r formula, we have the formula r squared is equal to s sub o minus s over s. S sub o pala, sorry. Yeah. So substitute the values. So r squared is equal to 11.54 minus 0.304 over 11.54. So r squared is equal to 0.9737. And so this will be your r squared. So since this is close to 1, if this is close to 1, then it is good fit, no? So it is a good fit. Yan. Okay. So moving on, there might be cases that it might not follow a linear function, no? So let's say your data points might be curvy, so the linear regression might not be sufficient, ano? So we can also do the polynomial regression, which will be for the next video. So see you guys for the next video. Yeah.